Today's target is based off of target 10b. Identify the rates of change for linear and/or exponential functions. For constant rate of change, it relates to a linear function. Remember, a linear function is in the form of y equals mx plus b. A variable rate of change relates to an exponential function, which is written as y equals a sub 1, parentheses 1 plus or minus r to the x power. If you need a reminder of how a linear function looks, remember a linear function is in the form of a line versus a variable rate of change is in the form of a curve. For part 1, label each graph as having a constant or a variable rate of change. For the first graph, we look and we see it is a curved graph, however, it's not an exponential graph, so it does not apply. Next one, we have a linear function because it's in the form of a line. Since it's in the form of a line, it's considered a constant rate of change. Next one, we do have a graph that consists of a curve. However, it is not an exponential curve, so it does not apply. Next one, we do have a graph with a curve. Is it exponential? Yes. It starts off very slow and then it quickly increases at a very fast rate. It is going to be considered a variable rate of change. Next one, we have the last graph. Same thing, it's in the form of a line. Since it's in the form of a line, it will be a constant rate of change. For number 2, which function has an increasing variable rate of change? So first off, in order for it to be a variable rate of change, x has to be the exponent. So if we look at every single option, we notice that option B is 2x plus b. That's actually a linear function, which would be a constant rate of change. So it is not an option we are looking for. Next, if we keep looking down the list, we notice that D is 6x squared. Although it does have an exponent, the exponent is not x. It's actually 2, which makes it a quadratic, thus eliminating it as a possible answer. So our only two options right now is A and C. A is 2.6 to the x power. C is 6 parentheses 0.60 to the x power. So right now we're going to focus on the 2.6 and the 0.60. Remember, in order for it to be a positive increasing rate, that number has to be greater than 1. The only one that has the option that is greater than 1 is A. Because of the 0.60, that's actually a decreasing variable rate of change, and that is not what we are looking for. So we're going to practice one more time. Number 3, which function has an increasing variable rate of change? So first off, let's start by eliminating what can we get rid of. I could see that I have 3.2 to the x power. So far that's an option. Next one is 3x plus 5. That's actually a linear function, so it is not our answer. Next one, 2 parentheses 0.50 to the x power. It does have x as an exponent, so I'm going to leave that one there for now. Last but not least, 2x squared. It still has an exponent, however, it's a quadratic, not an exponential function. So it is not our answer. We're left again with option A and option C. Option A has a 3.2. Option C has a 0.50. Because of that 0.50, it's actually a decreasing function. Again, I want it to be increasing. Therefore, A is my only option. Number 4. Greg needs to read a book that is 500 pages long. The graph shown at the right shows his progress over the first 6 hours of reading. If he continues to read at the same rate, how many hours total will it take for Greg to read the entire book? So first off, because it mentioned the word same rate, this is actually a linear function. So we're going to have to first create an equation in the form of y equals mx plus b. Remember, m stands for your slope and b stands for your y-intercept. So those, first off, we're going to have to identify both of them. I usually like to do the easier one, especially if they give us a graph. We're going to solve for b first. B is the y-intercept. Where did the graph cross the y-axis? This one's actually pretty easy. It crossed it at 0. So b equals 0 in this equation. Next up, we're going to have to find the slope. Remember, for slope, you need 2 ordered pairs. The good thing about this problem, it actually provides us with both points. We got 2, 52, and we have 6, 156. So again, I like to do extra stuff, so I'm always going to pre-label x1, y1, x2, y2. Remember, our slope equation is y2 minus y1 all over x2 minus x1. So let's start by substituting those values in. So I'm going to start with 156 minus 52 all over 6 minus 2. I'm going to simplify step by step. 156 minus 52 is 104. 6 minus 2 is 4. Next step is I'm going to check. Can I simplify 104 divided by 4? So that's what you're going to end up checking in your calculator. So we're going to try it out. 104 divided by 4, that comes out to equal 26. So when we go back to simplify, 104 divided by 4 equals 26. So now that I found my slope and my y-intercept, I'm going to create my equation. Y equals 26x plus 0. However, if you notice, it looks kind of funny for the fact that we have a plus 0. Normally, we never see that in an equation. So I'm actually going to simplify one more time, and it's going to become y equals 26x. And that's our function. However, we're still not done with our problem. It's asking us how many hours total will it take for Greg to read the entire book. So we got to go back to the problem. It tells us that the book consists of 500 pages long. So my bad, I started coughing. So we're going to continue this problem by plugging in 500 in for y. So it's going to be 500 equals 26x. Again, just like any other linear function, we're trying to get x to be by itself. So it's 500 equals 26x. 26 is being multiplied to x. So in order for us to solve for x, we have to do the opposite operation of multiplication. The opposite operation of multiplication is division. So that simplifies. We're left with x equals 500 divided by 26. 500 divided by 26. Again, I don't know if this is going to come out to be a good number. So just in case, I'm going to add that period just for me to be able to get a decimal back. And I did end up getting a decimal. 19.2308. I'm actually going to leave it as 19.23. All right, we're going to see this problem one more time. Kate needs to save $2,000 for a vacation. The graph shows her progress over the first 10 weeks of saving. If she continues to save at the same rate, how many weeks will it take for Kate to save the entire amount? All right, so our keyword here is same rate. Because it's the same rate, it's going to be a linear function. So again, we're going to create another equation in the form of y equals mx plus b. B is going to be our y-intercept. M represents our slope. So again, I usually start off with the easier one. The y-intercept is where our graph starts. Here, our graph starts at 30. Next up, we move on to slope. So again, this problem is actually going to be providing you both points that you should be using, 2, 40 and 7, 65. So again, I like to pre-label x1, y1, x2, y2. So it's going to be 65 minus 40 all over 7 minus 2. Again, I'm going to simplify step by step. 65 minus 40 is 25, all over 7 minus 2, which is 5. 25 divided by 5 can simplify, and it simplifies to 5. Now that I found my slope and my y-intercept, I'm going to put it back into y equals 5x plus 30. So same thing like the other one, K has to save 2,000 for this vacation. So we're going to actually substitute 2,000 in for y. So our equation is going to be 2,000 equals 5x plus 30. Again, we're working to get x by itself. So first off, I'm going to get rid of the plus 30. Since I'm adding the 30, I'm actually going to do the opposite and subtract 30 to both sides of the equal sign. That eliminates, and I'm left with 5x equals 1,970. Last but not least, I'm left with 5x, so I'm going to divide both sides by 5. That eliminates, and I'm left with x equals, let me check that in the calculator, 1,970 divided by 5. I'm going to put a decimal just in case, equals 394. So it's going to take her 394 weeks to save up the $2,000 for her vacation.